Hi, so we've looked at how we can create and project multiple dimensions onto our two-dimensional computer screens using aesthetics. So we've gotten up to 5 dimensions using some pretty basic aesthetics. But how do we get beyond that? You know, we're still stuck on 2 dimensions, projecting up till maybe 5. And an obvious way to do that is we've only ever had one pair of axes on each of those plots, a vertical axis and a horizontal axis. So now we're going to look at different ways you can use a multi-axis plot. And that's going to help us break out of this mold of just having 2 spatial dimensions. And we can have quite a few more. So let me show you 2 different ways you can create multi-axis plots. So my screen here is the first method we're going to use. It's called a pairwise scatter plot. And I'm going to create this plot for 6 numeric variables, 5 numeric variables and 1 categorical variable, which is curb weight, engine size, horsepower, city miles per gallon. Those are numeric, price, and then fuel type. And from the Seaborn package, we're going to create what's called a pair plot. And we're going to do it of these numeric columns. We're going to use hue, which is shades of color, is hue, for the fuel type. That's our 1 categorical column. I've picked a palette. There's palettes you can see in the Seaborn documentation. I've used this particular one here. On the diagonal of this plot, I'm going to have a kernel density estimation plot. I'm going to make the point size 2. And then, okay, it's a matrix, right? So there's an upper and lower triangular part. So on the upper part, I can also put 2D KDE plots. And I'm going to use CMAP as the color map. I'm going to use a certain blue shade for that. So let me go ahead and make that plot. And we'll talk about how we interpret it. Okay, so there's quite a bit of information here. So first off, let me orient you to how to read this plot. Recall we had 5 numeric columns. We had price, we had city miles per gallon, horsepower, engine size, curb weight. So you see those are the vertical axes here, but they're also the horizontal axes: price, city miles per gallon, horsepower, engine size, curb weight. So so we have these scatter plots. This is every possible pairwise scatter plot of those 5 variables. But then on the diagonal, say for curb weight and curb weight, we have 2 KDE plots, which are the KDE plots for standard and turbo, gasoline and diesel cars. And again, you can see, for example, here for engine size, we have gasoline and diesel cars, etc. So we see the KDE plots for the 2 types. And similarly, we've got our diesel cars in orange and our gasoline cars in the green dots. And so in some of these, like city miles per gallon and curb weight, we see a really clear relationship between how the diesel cars trend differently from the gasoline cars. You can also see that in the contour plot. There's really kind of complicated relations. And in some of these, like engine size versus horsepower, not too surprisingly, you see sort of a definite mode here in the 2D contour plot, and then some other little modes. And these are just like we saw before. They're 2D kernel density estimation plots. So they're just like a topo map of a hill. And you see the mode here of curb weight and price. We got price going out here. And notice that the points are projected underneath. Sometimes, and that helps you because recall the contours don't always incorporate the outliers here. So it could take a long time to actually study a plot like this, and I'll let you do that on your own, but that's basically how you read it. And so now we've projected quite a few dimensions here. We have 5 numeric dimensions and 1 categorical dimension. So total is 6 dimensions on this plot, but we could also do other things with shape or whatever and put even more dimensions on this scatter plot matrix. So another different way of building a multi-axis plot is what we call a conditioned plot or a faceted plot. And Seaborn has methods to do that. And so what you do is, remember we were originally just creating a simple grid. Now we're going to create something called a facet grid. And I'm going to define a column and I'm calling it grid column. And grid column I'm going to define as drive wheels. And so well, let me just make this plot and then I can explain what's going on. And we're going to do it for 5 numeric variables. We're going to look by drive wheels. So what has this done? It's done a group by. It's a group by operation. So these plots, first off, notice that the vertical axis and the horizontal axis are exactly the same for this group of 3 plots. So across the column here, the 3 columns, I have 3 histograms because that's what I said I wanted. My plot method inside this map call is hist. And so I have 3 histograms that I can compare directly, and I've got it for drive wheels equals rear wheel drive, front wheel drive, and 4-wheel drive. And I can see generally my longest cars are rear wheel drive cars, and the front wheel drive cars tend to be the shortest, and the 4-wheel drive cars are somewhere in the middle, etc. So I've done this for these many different columns. Let's go to the label. Our label value is price. So again, you see the price on the horizontal axis is exactly the same numeric range. And then it's grouped by drive wheels. And the vertical counts are exactly the same. So you can directly compare that front wheel drive cars, they really are accounting for a lot of that pile up of cars we had of low cost cars. They're almost all front wheel drive. There are some low cost rear wheel drive cars, and all our really expensive cars are also rear wheel drive cars. So it has the widest range, and there just aren't that many 4-wheel drive cars. So that's one way to, and we call this a conditioned variable or a faceted variable because we're conditioning it on, basically doing a group by on, in this case, a categorical variable that we specified, drive wheels. And we can extend this. We can do this now in 2 dimensions. So we're going to go drive wheels on the columns, body style on the row. So when I build my facet, so that's my facet grid. So I'm now going to have a 2-dimensional grid, and I'm just going to do this for 3 numeric variables: curb weight, engine size, city, miles per gallon, versus price, okay? So you can see price always on the vertical axis here, then curb weight on the horizontal axis in this first set of plots. And you can see body style is convertible, hatchback, sedan, wagon. And then I have this grid. This is my facet grid of scatter plots for those groups. Well, you can see some of these are empty. For example, there are no 4-wheel drive convertible cars. There's only 1 front-wheel drive convertible car. And you can see the convertibles, and they're kind of interesting. They're quite expensive, and some of them are actually pretty heavy. If you compare those to, say, the sedans or the hatchbacks, you see the hatchbacks are all low priced and all fairly moderate priced. The sedans are more spread out. And you can see there are some diesel cars spread in here. So you start to look at rear-wheel drive hatchbacks. There aren't very many. A lot of front-wheel drive hatchbacks. And guess what? They're all, for the weight, they all seem to be lower cost than these few rear-wheel drive hatchbacks. Our sedans seem to be sort of mixed half and half between rear-wheel drive and front-wheel drive, but our front-wheel drive sedans tend to be the more expensive ones, and the front-wheel drive ones tend to be the cheap ones. So again, you could spend a lot of time understanding these plots by weight and by, say, city miles per gallon. Again, you can see quite a difference in the sedans between front-wheel drive, or rear-wheel drive, sorry, and front-wheel drive. And there's even a few four-wheel drive sedans which seem to be kind of just off by themselves. So those are two different methods where you create many axes on the same plot. We did a scatter plot matrix which systematically creates the all possible pairwise combinations, and we took advantage of the fact that we could make a different kind of plot below and above the diagonal, and we could have put different plots on the diagonal. In this case, we used kernel density estimation plots. Another very powerful method is this faceting or conditioning method, sometimes also called the method of small multiples. And in that, we're doing a group by, and then we build a grid. It could be a one-dimensional grid or a two-dimensional grid of axes, which we are on exactly the same horizontal and vertical scale. So we can directly compare different groupings of our data. And if you have very large data sets, that starts to make a lot of sense. You'll see a lot more patterns. In this case, we only had 195 cars, so we even had empty plots on our grid. But with larger data sets, you start to see much more pattern.